Raw silk, the product of the reeling industry, is the continuous filament spun by the silkworm. It is obtained by undoing the silk cocoon. That marvelous structure which the silk builds around itself before its metamorphosis into moth. The earliest authentic reference to silk is to be found in the chronicles of Chou King of China 2200 BC, where silk is reported to have played a prominent role in public ceremonies as a symbol of homage to emperors. Legend attributes the unraveling of silk secret to the Chinese empress Xi Lingxi when she was sitting under a mulberry tree, accidentally fell into the tea cup. Attempting to remove the cocoon, she discovered that she could unwind a very fine glistering thread from the softened cocoon. The origin of silk reeling industry dates back to immemorial times in China, very likely to about 2400 BC, when the Empress Shi Lingqi started to domesticate and raise silkworms and discovered how to unwind their cocoons. A brief analysis on historical materials regarding Chinese silk industries shows that in China, the raw material production obtained constant support from the government of successive dynasties. As for the silk goods making, it seemingly occupied a marginal place in Chinese historiography. To explain this phenomenon only by the desire of Chinese silk craftsmen to keep their professional secret would seem to bias. It will be more objective to consider the long history of silk industry in China in the context of the Confucian ideology of sobriety and of the anti-meriantic policies often implemented by Chinese rulers. The 18th century had known a rapid expansion of the technical development of silk making. After a long period of research, the efforts to speed up the progress in sericulture knowledge and in the silk making process paid back with remarkable results during the first half of the 19th century. The technical development of silk reeling during Japan's early industrialization followed a distinctive pattern. Unlike other modern industries introduced from the West, silk reeling was characterized by a combination of indigenous Japanese technology developed during the Tokugawa period and advanced Western technology. The technological development in the silk reeling industry from the Meiji era to the end of Second World War can be divided into three major periods. Number one, the early 1870s, when Western technology for mechanized silk reeling was introduced. Number two, from about 1875 to 19, when mechanized silk reeling was transformed and adapted to indigenous conditions and diffused through Japan. And number three, from the early 19th to 1945, a period that saw major improvements and innovations in mechanized silk reeling, such as the multiple spool reeler. A fourth period can be designated based on the introduction of the automatic reeling machine, but this occurred in the 1950s and is beyond the scope of this essay. The process of introducing the adopting foreign technologies cannot be viewed separately from the historical and social conditions of the recipient country. There are Shang pictographs written in various ways which may be interpreted as being concerned with silk reeling. In the opinion of Chinese scholars, they show hands arranging silk threads on a reel-shaped device to take the silk. In short, they picture working a silk reel by hand. Yet, though silk reeling can be performed with a reel, there is neither definite textual or pictorial proof for it prior to Chou or Sung times. The Shang and Chou silk reeling device cocoons are floating in a water basin on a stove, while the filaments from the cocoons are drawn off combined by hand and wound onto a small reel in front of the worker. Apart from the fire in the stove, which is not needed in the cold water reeling method, no simpler reeling device could have worked efficiently. The reeling frame, which most probably followed these simple types, may have been a hand-operated cold or hot water reel. At first, it may have been small, operated by one person, but in the course of time, it developed into a large device operated by two persons. The southern silk reeling frame, it was easier for reeling because it was smaller and simpler to control, as well as to turn or stop and to change. The four-sided reel was equipped with both immovable fixed spokes and movable ones. The four rails were attached to their tops. In this method, inserting the spokes to the horizontal groove was chiseled out in the axle in which to place the spokes, and a wedge was knocked into the intermediate space to fix them. The wedge penetrated through the axle. If one hit the board end, the spokes were set in very tight. If one hit the sharp end, the spokes could be taken off. When reeling silk, the fibers are drawn up from the surface of the pan filled with water. They pass through the guide eye and ascend to the roller. The rollers correspond in their motion to the silk reel. The threads then pass from the rollers to the ramping board and hence to the reel. Then the reeling of silk on the reel is perfected. The reel has a length of about 60 centimeter in its diameter, in the mid of the nearly 12 centimeter, and at the ends of both sides at about 6 centimeter. Elm and Sophera japonica wood are used to make the 4 or 6 sided reels. The length of the spokes is about 105 centimeter. The 6 sided reel is not like the 4 sided, because if the reel is small, then the silk can easily be taken off. Coming to the northern silk reeling frame, in this type of reeling frame of the silk reel and the pan are equally high. The axle is about 60 centimeter long. Its diameter in the middle measures some 12 centimeter. At the ends of both sides about 9 centimeter. The bamboo rollers of the silk reeling frame should be fine and small, like the rollers of the production of thin tabby silks. Iron spindles perforate the rollers. The two posts of the roller frame should be made of iron. The two vertical posts are horizontally penetrated at their tops by the iron spindle. The iron spindle runs through the rollers. When this is the case, then it is handy and advantageous to operate. Roller systems. The butterfly eyebrow roller. Roller system spindles fitted into two bamboo or iron posts fixed to a board placed on the rim of the pan and stretching across the water surface. The board was weighed down by stones and wedged between both upright handles of the pan. The roller were necessary both for the transport of the threads and in the evening and rounding process. Reeling silk, one worker is needed who takes at least about 50 cleared silk fibers from the wood silk pin to which they had been attached after the preparatory work had been finished prior to reeling. Yellow silk is coarse, and so if the silk is of this color, the number of cocoons should be reduced. The silk fibers from the cocoons are gathered together in one place so that when the reeling starts, threads can pass through the guiding eye. The place below the guiding eye where the cocoons are gathered is called cocoon assembly. Another name for it is stirring pan. The threads wind twice round the top roller and twice round the bottom roller of the butterfly eyebrow. Finally, threads are drawn onto the silk reel. Soundless roller silk reeling frame. From an historical point of view, it can be regarded the joining link between other advanced frames and the simple reeling devices as they are pictured on the hand scroll silk workshop in the quarters of the palace ladies by Chu Ying of the 16th century, and in the Pin Tung Ushi Hai Chu Ti of 1607. This frame, which seems to have developed from such simple devices, may have been a hand-operated hot water reel with two long ports and a crossbar at a top, and provided with a hook to guide the thread. In all probability, it was only a small step to make hook movable with the help of a movable crossbar, which arranged in the ramping board. This was a very simple but original idea, resulting in a ramping board, which guaranteed the same results as the more complex silk reeling machine. Japanese indigenous silk reeling technology had achieved a high level of development, but during the Tokugawa period, it remained at the hand reeling stage. Two slightly different reeling techniques were widespread at that time. Some of the reeling technologies used in Japan are dotoriki kai. In ancient times, a crude contraption known as dotoriki kai was used for reeling in Japan. It consisted of a cylindrical piece of light wood about 12.5 centimeter in diameter and 60 centimeter in length. This was fixed on extended axis loosely held at either ends of supports about 15 centimeter high, close in front of the cylinder, which served the purpose of a modern reel, a crude oven. Actually, an open fireplace was lifted and a pot or can with water was placed on it and the water boiled. The cocoon for reeling were cooked in the boiling water and manipulated with a pair of wooden prongs. When the cocoons were cooked, the reeler gathered 5 or 6 filaments from the many cocoons and wound them on the cylindrical after twisting the several filaments taken by rubbing the filaments between the palms. The reel was then turned to revolve. Reeling was not a continuous process, but halting on account of the elaborate twisting of the silk filaments that had to be done before the silk was wound on the cylinder. The silk produced were crude, uneven in size, and poor in cohesion and cleanness. Teguriki kai, later an improved model called Teguriki kai, was used until about the mid of the last century. It consisted of a rectangular reel 75 centimeter in circumference with an extended axle resting loosely on upright supports. One end of the axis was provided with a bamboo handle for turning the reel. The height of the upright support, the reel was fixed according to the conveniences of the reeler. The reeler turned the reel with the right hand and manipulated the silk with the left, simultaneously drawing and twisting the drawn filaments and winding the silk on reel. Coming to the Jaguriki kai, this sedentary type reeling equipment was introduced later. The circumference of the reel in this equipment was about 53 centimeter with 4 reel bars. The improved aspects of the equipment were a bamboo distributor, a thread guide, V-shaped bars, wire loops or brackets for application of crozier, and fixture of a wide-mouthed amalgamated basin over a well-constructed oven in which a coal or charcoal was burnt to avoid smoke. In this equipment, Two ends were conveniently reeled and the mechanical improvements affected in the equipment enabled quicker reeling of better quality of silk than in either Dotori or Taguri. Coming to the hand reeling machinery of Japan, as long as the preparation of filaments and casting of ends keep the silk thread continue to remain manual operation, the process is known as hand reeling as against machine reeling. Although the reel are driven by power and water is heated by steam, the reeling is still hand reeling because the filament casting is dependent on the silk of the hand only. The cooking and reeling basin water is heated by steam from the central heater. The following features characterize the hand reeling machinery. In this method, the cocoons are cooked separately in an open pan and reeling is done in a specially designed basin. The temperature in the reeling and cooking basin is maintained at different levels. The speed of the reels and the number of ends and increased appreciably to increase productivity. The reels are kept at the back of the reeler with facility for prompt knotting of broken threads and also to allow silk to dry before reaching the reel. Porcelain button guides, mechanical hand brakes for each reel and bevel gear system of traverse are incorporated, keeping the general mechanism simple and the cost of construction low. French and Italian scientists made significant contributions to the growth of the modern reeling industry. The word controversies used in reeling were considerably improved both in design and construction. The direct reeling machine with a number of mechanical gadgets laid the foundation for further improved models like the multi-end automatic reeling machine. It would be interesting at this stage to mention the essential parts of the machine to understand the evolution of the most sophisticated reeling machine of Japan. So, the direct reeling machine designed for reeling a silk hang of 150 centimeter circumference in conformity with international standards was largely popular in Europe. The silk reeled by this method can be directly used for winding operations, which is the first operation in the conversion of raw silk into twisted silk yarn. This was the forerunner of the hand reeling machine of Japan described earlier. It differs from the hand reeling machine in certain respects. Example, the cooking basin for every set of two reeling basins was provided with automatic brushing arrangement. The reeling basins was served by a separate and preparation basin as well as a jetty board. The standard reels were encased with a built-in heating arrangement and each reel was provided with an independent traverse. Reel bench, separate cooking basin with mechanical brushing arrangement, reeling basin, crozier frame, preparation basin, reel box, standard reels, individual traverse mechanism, inbuilt heating arrangements for drying silk. The Western silk reeling technology was exported to other countries like Japan and India, etc. even as early as 1867 to 1868. The first organized filature in Japan was established at Tomika in 1869 with European technical assistance. In India, these basins were also first introduced in Kashmir state, where only univoltine cocoons are produced. In India, these European machines were introduced in other multivoltine states as in a modified form, retaining the essentials. The modified versions were made locally with a view to keep down the cost and also to suit the conditions peculiar to each sericulture area, which offers different qualities of cocoons of both pure and hybrid races. India, with diverse climatic conditions and a diverse fauna of silkworms, offers a variety of reeling equipments and organizational patterns, from simple charaka in the cottage sector to the multi-end reeling machines in organized filatures, as may be seen. Improvement and innovation in mechanized silk reeling. In Japan, an automatic reeling machine was originally invented in 1901 and continuously developed until 1941, but the new invention has not found to be convenient for reeling 13 to 15 denier raw silk, which was the most popular size in demand, and the machine was not industrially adopted. It was only 1946 onwards when the demand switched to 20 to 22 denier silk, and simultaneously there was a sudden demand for labor for higher wages, that it becomes necessary for Japan to adopt automatic reeling machines. Since 1952, these machines have increased in popularity, and currently the bulk of raw silk production in Japan is from automatic reeling machines. Automatic reeling machines were also invented independently in Italy and France. It is said that an American engineer, Edward William Serrell, invented an automatic reeling machine in 1880s to 1885. The machine was served by an automatic size regulator which was operated by the tension of the reeled thread. Later, Bessinilla Florizzi derived another type of automatic machine which had a device for maintaining a constant number of cocoons in the reeling end. Rene Azamand invented an apparatus for reeling which could adjust the size of thread by the change in elongation. In 1952, the Ba-Ka-Pa type machine, which was originally invented by Balbirin Carnovay and Penzilla, was completed in Italy. As the name suggests, the reeling of cocoons is done by mechanization through various processes involved in cocoon boiling, brushing and picking and feeding and reeling of filaments of the cocoons. In the evolution and designing of an automatic reeling machine, spectacular strides were registered after 1950s when more and more electronic measuring aids came into use in the field of industrial research and planning. In this respect, it should be made clear that the introduction of Western technology did not mean the mere import of foreign modules. The silk industry, it actively introduced Western technology but took local conditions and the state of indigenous technology into account. Moreover, with the diffusion of mechanized silk reeling technology was further modified and adapted to local conditions.